Hello everyone. So today we're going to solve this problem expressed as sum of power of natural numbers. So in this problem we are given two numbers. One is the natural number and second is the power. So what we have to do is express the sum as the xth power of x unique xth power of unique natural numbers. And we have to return the possibilities in which we can express, all right? And we have to take the mod 10 power 9 plus 7. This we do when in case of integer overflow, all right? So let me explain this test case through Jamboard. So in the first case, we have n equals 2 and x equals, sorry, n equals 10 and x equals 2. So let us understand this through recursion tree. So this 10 can be expressed as 1 square plus 3 square, right? So this 3 square is 9 and 1 square is 1. We have 10. So like this, we have to return the number of ways in which we can express this natural number n in the form of squares of these natural numbers 3 and 1. So we will be using, since the topic tags are recursion dynamic programming, so we'll be using take or not take technique in this problem. So in the we will start from 1, all right? So we can subtract 1 square from this 10, or we don't wish to subtract this 1 square from 10. So in that case, it would be 10 as it is, and it would be 9. Now, since we are given, we have to return the sum of unique natural numbers. So we cannot take this 1 square again. So we will be taking 2. So we don't wish to subtract this 2 square. So 10 remains 10 itself. And in this case, it's 10 minus 2 square, which is 6. And in this case, it's 9. And in this case, it's 5. Now we have 10, 6, and 9, and 5. So we have now 3. Correct. So for 3, we have 3, 10 minus 3 square, which is 9. And 10 minus 9 is 1. So if we wish to subtract this 3 square from 10, we get 1. And similarly, for this case, for 6, we can subtract and we can't subtract. And in case we subtract, the answer would be a negative number, which is minus 3. And if we don't, the 6 remains 6 itself. And in this case, we have 9 and 0. And in this case, a negative number and 5. So as soon as we get a 0, we stop. Okay. This means that we have got our answer. So how are we solving this problem? So we have we can express this 10 as 1 square plus 3 square, right? And in the second test case, we have n equals 100. So 100 we can express as 6 square plus 8 square. That's one possible way. Second possible way is express it as 10 square. And a third possible way they have given as 1 square plus 3 square plus 4 square and so on. So there are total 3 possible ways. So let us, I'll be using the first the brute force recursion, and then we'll be optimizing it by memorization technique. So let me write the brute force recursion code first. So in that case, since we will be using a temp variable, which which will be 1, then 2, and in the next iteration it will be 3, like this, and so on, till it reaches n. All right. So what are the base cases of recursion? So since I told I will be using the temp variable, and we we cannot modify the original function since it will give the error. So we'll be using an helper function, which is nothing but an overloaded function. So we'll be returning our answer through this function. All right. So we'll be passing n, x, and initially the temp would be 1. Since we are considering the natural numbers, right? Natural number starts from 1. So if any case n equals 0, then we return our answer as 1. That so we have one possible way, all right? And in any case, n goes less than 0 or our temp variable exceeds our temp, then we return 0 in that case. That means stop. Else, what are we going to do? We are going to call this recursion on. So we have two choices, right? Consider it or not consider it. So in both of the cases, temp will be exceeding by 1. We'll be incrementing the temp by 1. So in case of considering the temp, we'll be subtracting the power. So as you can see, when we considered temp, then the answer is 10, which is n, minus temp. This 1 is temp. This 1, 2, and 3 is temp. So n minus temp square. All right. So since we cannot express this temp square in C++, so we'll be using the power function. So temp comma x. X is 2, nothing but 2. And uh, in the next choice, we don't consider the temp variable to get subtracted by n. All right. So n remains n itself. All right. This 10 remains the same. So in the end, we return the answer as a plus b. The number of ways would be sum of these two calls. Okay. So let us compile and run and check if we did anything wrong. So 10 comma 100 comma 2 it's working fine, and 10 comma 2 it's working fine. So I know we'll get TLE at like 591th case. Oh, 570. So let us optimize our code. So in order to do that, first we'll create an array. We'll create an output array. So what would the dimensions of output array? In memorization, we know that the dimensions of the output array are the changing parameters, the parameters which are changing. So in this brute force recursion code, we see that value of 10 is varying and the value of temp is varying as well. So the size of output array, so we'll be using a vector of int output of size n plus 1, comma vector of int of n plus 1, comma minus. Since our n is going from 10 to 0, all right, we are stopping at 0 and going from n. So we will take the size of array as n plus 1. Since if we take n size, the array would be created like n 0 to n minus 1. So that's the reason of taking n plus 1. So in the second case, we have the size of the temp array. So it will also initialize from 1 and go till n. All right. We stop at n. All right. So I have taken from n plus 1. You can try it with n. So that's why we have taken the output array as n plus 1 cross n plus 1. So now let us pass this array as well. I've passed this array and let us grab this array here by reference so that changes we made are permanent. There shouldn't be any copy created. And before evaluating our answer, we must check if the answer exists. So the second thing is check if answer exists. These are the steps of memorization. Check if answer exists in array. So let's check if output of n and temp not equals -1. Since we have initialized our array is -1, so if the value is not -1, this means our answer exists in that particular row and column. So we return it temp, all right, else we evaluate the answer. And before returning the answer, we should save the answer. Output of n comma temp equals a plus p, and return here. And in order to not face n plus 1, the overflow, we'll be using the mode variable, which would be 10 power 9 plus 7. So while returning, we will take the mod. Okay, take the mod, and yes, this should do it. Let us check. So 400. Let's hope it gets submitted. It should. So yeah, that was it. If you have any doubts, let me know in the comments. Thank you.